Okay, so today we're going to be going through hopefully the rest of the PowerPoint. We'll see how far we go. So the first thing we're looking at today is inferential statistics, and you've already gone through inferential statistics last year. Inferential statistics are basically statistics that allow us to make predictions about what the data is telling us. So in other words, inferential statistics are mainly used to kind of make statements about, okay, what is the conclusion going to be for the study? Can we generalize the results? What do these results actually mean? So whenever you're, for example, writing stuff in your discussion section as to what the results mean, what the conclusions are, what the real life implications are of this study and of the results, these all are usually determined by our inferential statistics. Now, inferential statistics are different from descriptive statistics. Okay, descriptive statistics are like a mean, median, and mode. They're mainly used to display data, to give us a typical value, for example, a mean value of score. Inferential statistics don't give us a typical value or a mean value of score. They're not used to present data. They simply help us to make inferences. Okay, when I'm making an inference, I'm essentially making a prediction about the data or about the results that we've obtained from that study or from that experiment. So number one, inferential statistics help researchers to interpret the meaning of the data. Inferential statistics can also play a place in conjunction to other factors in determining the reliability of a data set or reliability of a set of scores. Inferential statistics can also help us to determine whether the results support the hypothesis. A lot of the time researchers do calculate a p-value, and that p-value in conjunction to other factors can help them to decide whether the hypothesis is supported or not by the results. And the third thing is, obviously, like I said before, inferential statistics can help us to determine whether we can generalize the results that we obtained back to the population or back to the broader population from which the sample was drawn. So obviously the main example of an inferential statistic you would have learnt about last year was the p-value. I think a lot of you remember p less than 0.05 is the p-value of statistical significance, that if your results are statistically significant, then that is like one step closer for you in terms of generalizing your results. The good news is, however, that according to, I think last year or the year before, like I attended like a VCAR kind of seminar thing, and they were saying that in terms of the new study design, which started in 2017, like they're not going to be looking at p-values as much anymore. So you would have noticed that in a lot of the case studies I put in your quiz yesterday, those were taken from past VCAR exams, but I didn't actually mention the parts where the p-value was discussed. Okay, so I've just taken out questions about p-value. Also in past, if you look at the past year's exams from 2017, there's nothing about p-value whenever research methods is included in any question. So, and I have attached the slide from that PowerPoint they gave us here. So obviously when we're talking about the mathematical or what do you need to know in terms of maths for psychology, p-values are no longer required. So you don't need to know how to write a statement or write a description of a p-value. You don't need to know, don't need to be able to evaluate what a p-value is. So if it's p equals 0.03, you don't need to explain what that is, okay? In the previous study design, like prior to 2017, that was something that students had to do. And in fact, if you remember correctly, even in our PowerPoint last year, there were a few slides on p-values, okay, which have been removed in this PowerPoint. So what do you actually need to know then? What you need to know is, first of all, you need to know how to present data from tables as bar charts or line graphs. So if they give you a bunch of data in a SAC or in an exam situation, you should be able to make a bar graph out of that, okay, or draw a line graph or a histogram or like a bar graph out of that. That's pretty easy if they've already given you the data. I think in 2017 VCAR exam, they did ask students to draw a graph. So you should have enough knowledge to be able to draw a bar graph if they give you that data or if they give you that information. Okay, that's easy work, easy peasy. You guys have been doing this from like year 6 or year 7 maths. You need to know percentages. Basically, you're not going to ever be asked to calculate some complex percentage that you'd need a calculator for. Obviously, we know calculators are not allowed in the VCE exam. But in terms of percentages, you should be able to read a percentage. If they give you a graph or they give you a table, you should be able to read a percentage and know that a percentage is always out of 100, okay? Common sense, literally. You should be able to know how means are calculated. Now we know, all of us should know, having done up to year 10 maths, how to calculate a mean value, how to calculate an average. Okay, you add everything, you divide by the number of values. Easy peasy. If VCAR give you a bunch of numbers in a question or say that these were the scores obtained in the study, what is the mean value? You should be able to calculate that by hand and choose the correct answer. And as we did yesterday, you need to be able to understand the standard deviation as a measure of variation around the mean, and that it supports us in terms of understanding what the mean is actually telling us, okay? You won't be asked to calculate standard deviation, but you should have a basic knowledge that if something is 3 standard deviations away from the mean, that represents a very unique or uncommon kind of proportion of the population, or like one extreme of the population, because it's on one side of the standard deviation graph, as compared to something being just 1 standard deviation from the mean, where it's a lot closer to the mean value. Okay, so you just need to be able to understand what the standard deviations mean in terms of where they might be located on that normal distribution. But in terms of an actual calculation of that, no, you would never be asked to calculate that. Okay, anything that you'd require a calculator for, you will never ever be asked to do that. Just basic stuff like addition is something you might be asked to do, but other than that, yeah, everything else should be easy peasy. Okay, so moving on. Now, everything that we've done, like in terms of our extraneous potential confounding variables, in terms of our research designs, in terms of our standard deviation, in terms of our reliability, in terms of validity, all those topics we've done all connect to this concept of conclusions and generalizations, okay? Depending on which research design you use, depending on the kind of potential confounding variables that might come out of that or might not come out of that, we will be able to better generalize our results, or maybe not generalize our results well at all. Okay, so obviously all of these, it's never just one factor that influences ability to generalize results. It's a range of factors. Okay, and so when we get back to school, we'll kind of brainstorm this a little bit more, but looking at the different factors that actually can influence a conclusion or a generalization. So obviously, before we look at that, we need to be able to know what a conclusion is and what a generalization is. A lot of us kind of use these terms interchangeably, but they are 2 different things, okay? So the first thing is a conclusion. Now, before a researcher or before an experimenter can actually make a generalization, they have to make a conclusion first. And a conclusion is basically a decision about what the results obtained from the research mean. If I'm going to go to a researcher and say, can you summarize your results for me? Tell me what your results mean in a few words. I don't have time to read pages of your research paper. Just give it to me straight. Just tell me the, tell me the summary of the results. And then they give me a few sentences about what the summary of their results are, what their summary of the results mean in terms of like their study, in terms of real life, whatever. That is the conclusion that they have for their results. Okay, conclusions always need to be backed up by evidence. Similar to validity, it's similar to validity. We can't make a conclusion based on information that we just get out of thin air. We can't make a conclusion based on our own opinion. We can't make a conclusion based on what other people say. We always have to make a conclusion for our results based on our results, okay? The conclusion for our result has to be backed up by evidence, and that evidence is the result that the researcher is obtaining, okay? And based on that, they can say that yes, my hypothesis was supported, or no, my hypothesis wasn't supported. We don't care about whether hypotheses get supported or not, okay? But it's always about making sure that whether your hypothesis is supported or not is based on your results. That's extremely important. And like we said yesterday, the researcher should never be too quick or overconfident to conclude that their results do support the hypothesis, okay? Because again, their results could have been influenced by other variables, so unwanted variables, potential confounding variables, the research design, ethical breaches. All of those things can affect our ability to properly conclude and thus properly generalize the results. So obviously remember that if a researcher makes a conclusion that's not backed up by evidence, that's not reflected by their results, those results will automatically show low validity because the researcher is not backing up the results or backing up the hypothesis with the actual results that were obtained. So we always need to back up anything we say with evidence. Now, obviously, the generalization is influenced by what kind of conclusion is made. Okay, so the conclusion happens first and then the generalization happens after that. So the generalization is a more broader decision or judgment about how broadly we can apply the results of an experiment or research study, okay, particularly to the broader population from which the sample was drawn. Essentially what this means is that if my results are pretty good, my results are supported by the hypothesis, there's not much variables or extraneous or confounding variables that I can see or that I can note down from my study, I can then potentially go on to make a generalization. I can then say that, okay, because sleep deprivation affected driving ability for people aged 25 to 34 in this study, we can generalize these results and say that it will basically affect driving ability for any person aged 25 to 34 in the population or in Australia. So what we're doing is we're taking the results from our smaller scale study and we're applying it broadly to a bigger population or an entire population from which that sample was drawn, okay? So if it's 25 to 34-year-old Australians that were in your study, you can then apply that to 25 to 34-year-old Australians in the population in Australia, not to 25 to 34-year-olds in America, not to 25 to 34-year-olds in India, to the ones in Australia. Because remember, a generalization is always made from a sample back to the broader population from which we took that sample. Now, a number of factors can affect your generalizability of results, and we've kind of covered a lot of them as we've gone through this PowerPoint, but we will kind of touch upon them in the next slide as well. Okay. So when we're talking about evaluation of research in terms of generalizing findings to the population, this is just from the study design, basically, this terminology. So evaluation of research is how we're going to evaluate research. How are we going to evaluate our results? What are we going to make of our results? In terms of generalizing findings to the populations means basically what factors are going to affect my ability to generalize findings back to the population or generalize results back to the population. These are these dot points are all problematic things or problematic factors that will make it difficult for me to generalize my results. And these are the things that we want to look for when we read through research studies, okay? We want to look for these things because these are the kind of some of the surefire signs that a research study might not be generalizable. The first thing is a very small sample size. So if you've got a study that's only showing us the results of a few people, like 10, 20, 30 people, that's quite small, okay? There's no specific number, but obviously it's better for us to conduct a study with 100 or 200 people as compared to 10 or 20 people. Okay, so very small sample sizes only show us the results of a few people and can actually open up more space for individual participant differences. Because remember I said, the bigger that you make your sample, the more that individual participant differences kind of get balanced out. The next thing that could be a problem is the imbalanced gender sample. So if the study says, okay, this study recruited 20 males and 10 females to be participants in the study, well, we see that there are double the number of males than females. And so depending on what we're studying, that could give males an unfair advantage because they tend to skew the results a bit more because there's more males than females in the study. Again, it depends on what the actual study is about, but in most cases, you can pick out a gender sample that's imbalanced as a potential confounding variable as well. Okay, if the nature of the study's results does not apply to the common population, so if we're doing a case study on Jeannie, the child who was neglected that you guys learned about last year, or if we're doing a case study on HM or Phineas Gage, these people had rare disorders. They went through rare conditions or circumstances, and so we won't be able to generalize their results back to the population, okay? Even if we conduct a related experiment connected to them, still we can't generalize their results, okay? Because they are unique cases. We don't have a million Jeannies or a million Phineas Gages and HMs walking around in our population. They're not the typical person, okay? So they're a unique case. Individual participant differences that are not controlled for, these are the easiest to pick because you just look at, okay, what is a variable other than the IV that could be affecting the DV? So if it's a study on, let's say, like stamina and endurance during like athletic, during an athletic game or during a race, and we're testing the effect of a new energy drink in terms of allowing athletes to be more, to have more stamina and endurance while running a race. Obviously, there could be other factors that we can't control for. For example, how much each individual participant is training for outside of the actual race hours. The general kind of energy levels. What about nutrition? Nutrition will play a big role in terms of energy as well. Okay, if the person is eating a lot of crap outside the race and they're not eating very nutritious foods, they might burn out, even if they drink the energy drink prior to the race. So obviously there are other individual participant differences that we might not always be able to control for. Any potential confounding phenomenon or variable that could affect performance, for example, order effect, placebo effect, experimental effect, all of these potential confounding variables can affect a participant's performance and thus make it difficult to generalize the results. Non-standardized instructions and procedures, so that's obviously talking about two researchers, but they're not giving the same results. Or maybe one researcher, but they give the results to the experimental group, or they give the instructions to the experimental group in a much clearer way. But when they get to the control group, they're kind of like just waffling on and they're not really being clear. So that can affect participant performance as well, because one group knows a lot more and are a lot more clear about what they need to do. The other group doesn't know as much. So again, we talked about that with those two experimenter examples. And the last thing is, the last point is more to do with matched participants' designs. So if one participant's results become invalid or complete and their data is not removed, they obviously, that data will be invalid and that will end up maybe affecting our results. Or in the case of matched participant study, like I said, if one participant withdraws from the study, the other participants in that matched pair, the other participants' results will become useless and that we'll have to discard those results as well. Okay, so remember, whenever a participant leaves the study, when they exercise their withdrawal rights, we need to be able to throw away their results. Whatever results they've obtained so far for that participant need to be chucked out. And if they're not, they can actually render the results invalid later on. Okay, so it's better we chuck that out so it doesn't ruin the entire results that we have from the other participants. Okay, so this photo here just shows you, okay, the population, we select a sample from the population, and this, whatever the results we get from this sample here, end up going back to the population as well. Okay, so that's basically talking about what are the different factors that can lead to, you know, problems with generalizing results. And remember, these are just a few, but we have a lot more as well. But, you know, again, it depends on the study. So you could talk about the study not having enough lighting, if that's what the study was talking about. It really depends on the scenario as well. Okay, but these are just a few main examples. Alrighty. Why do I have another study? Oh, these are some examples here. Okay, so yeah, it can be difficult to generalize results based on the study that we are looking at. So obviously, if you're studying like the impact of sleep on driving abilities, you've got participants who are expert drivers who've driven for like 35 years as compared to drivers who have just driven for maybe 2 or 3 years. Then, well, these expert drivers will have an unfair advantage because even if they are sleep deprived, they are a little bit more skilled in driving to begin with. So they might be less likely to make mistakes. They've got more experience driving. Okay, so an extraneous or potential confounding variable is affecting performance in this example. Another thing that a lot of you might remember is that when we did our first second, we had a research methods question, we put in the fact that the participants at the end of the study received extra study points or extra points to their grade. This is always a problem. Some psychologists, like I remember when I was in uni and they were doing like the PhD graduates and stuff and professors were doing studies. They kind of just used us psychology students as guinea pigs sometimes for their studies. And so what they would do was they would like offer incentives. So they'd be like, oh, you know, if you do this study, you will be reimbursed $50 or you will be reimbursed a $20 gift voucher, or you will be reimbursed $40 to spend at the university bookshop or at the university cafe. And so a lot of students in between their free periods would be like, you know what, I'm going to get like a voucher for this. Let me just go and do it. And in fact, I've actually done that like once or twice as well. So the thing is that when you're luring in like participants like that, the only problem is that your participants might just be doing it to get the voucher or to get the money rather than doing it out of a sheer consideration for your research. Okay, they don't really give a crap about what research you get. They're just doing it because they want to get the gift voucher. And the quicker the participants can quickly finish your tests or your assessments and just get out of there, the happier they'll be. So they might not take it seriously. They might just choose any response. They might just say anything to make you happy as the researcher. So obviously, that's a problem with providing an incentive to participants. Asking ourselves, are they participating because they actually want to contribute to research, or are they just doing this to get my gift voucher or to get the money I'm offering? And the last thing, which is a little bit more obvious, is ethical breaches or violations. These are pretty obvious when they're in research studies. So a participant wanted to leave the study, but the experimenter persuaded them to stay. Okay, that would be a breach of withdrawal rights. If participants were forced to actually enter into the study in the first place, and they were told that if they don't participate, then they will get marks deducted from their SAC average. That's going to be a breach of voluntary participation. Okay, so obviously an ethical breach or violation, which we're going to go to next, I believe, automatically renders results ungeneralizable. Okay, you cannot generalize results where an ethical breach has been made, because ethical breaches are a clear limitation for the study. Okay, we don't call ethical breaches we can call them a confounding variable, but honestly, I'd say it's more correct for us to call them a limitation. Okay, because not all ethical breaches confound our DV, but all potential confounding variables do confound the DV. Alrighty, so looking at ethical principles now, we can probably run through these a bit quicker because they are pretty straightforward. The first thing we need to consider before we look at ethical principles is general ethical considerations in a study and the role of the experimenter. And you guys have done a lot of studies last year where you've looked at the role of the experimenter, okay? The Stanford Prison Experiment, this is just the little poster of the movie that they made on the Stanford Prison Experiment, I think last year or the year before. Philip Zimbardo was the experimenter in this particular experiment. And like, if you look at some of his interviews in recent years, he's like, I could have stopped it earlier. And he kind of has a regret because a lot of people gave him a lot of criticism for the fact that he kept the experiment running, even though he could have stopped it within the first day or second day, but he kind of still kept it running because he was curious to see how far it would go. Okay, that's a problem. And that kind of was him kind of compromising his role as a responsible and caring and considerate experimenter. We studied about Watson's little Albert experiment this year. Okay, this is Watson next to the baby here. And we studied that Watson didn't really give a crap about little Albert's feelings. Little Albert was clearly distressed, extremely upset, extremely affected, but obviously Watson didn't care. Watson just kept going. He just wanted to see how far he could push little Albert, okay, in terms of that white rat and the phobia and everything. So that's basically how Watson compromised his role as an experimenter. In the Milgram experiment, which was the electric shock, delivering the electric shock and the learner and the teacher thing you learned about last year, you might have watched the video where a lot of the participants just kept going, and the experimenter didn't really stop the experiment either. They wanted to see how far or what level of an electric shock each of the participants would deliver, and the experimenter was happy to keep that going. So that was an example of how Milgram actually kind of compromised his role as a responsible experimenter. Okay, so regardless of what experimenter you are, regardless of what researcher you are, you always need to keep your participants at the heart of your interest. Okay, whatever best interest the participants have, that has to be at the forefront of everything that you do. So number one, we have to obviously protect our participants. We have to prevent harm from occurring. As a researcher, you have to always maintain the safety, welfare, and well-being. This could be physical well-being, could be emotional well-being, could be mental well-being, could be social well-being, any of those dimensions. Okay, it doesn't always just have to relate to physical health or physical well-being. You need to always, like this is related to the standardized instructions and procedures, always delivering them in a clear way where each of the groups or each of the participants is getting communicated in the same way and being given the same attitude. Okay, if I've got participants and one participant seems super enthusiastic, but the other participant's like, oh my God, why do I have to be here? Just because that participant's giving me a bit of an attitude, I can't be like, okay, you know what? I'm going to give you an attitude too. In fact, here's one detail of the study. You can figure the rest out for yourself. I can't do that because then I'm giving one participant super clear instructions and the other one, I'm kind of giving them instructions with an attitude and not giving them the proper details. Okay, so we always have to make sure that standardized instructions and procedures are implemented. We have to make sure that there is a consistency in terms of how we are implementing our study. So again, that's related to the concept of reliability. And whatever ethical principles have been set out by ethics committees, which we're going to go through in the next few slides, we have to meet those ethical principles like withdrawal rights, informed consent, and all that stuff. Okay, so obviously a lot of you might be thinking, okay, if ethical principles are such a big deal, then how did researchers like Philip Zimbardo, John B. Watson, and Stanley Milgram get away with what they did? Well, they got away with it because they conducted their studies in a time in the 1940s, 1950s, 1960s, or even 1970s, where psychology ethics committees were not really, they were not clearly established as of yet. And so even the ones that did exist, they were pretty like easygoing. They were like, okay, you want to do a study? Yep, that's fine, just do it. As long as no one's getting killed, that's the main thing we're concerned about, okay? But they didn't realize that mental trauma and emotional trauma can actually come out of a study. And a lot of, especially with this prison experiment, one of the participants was actually like, he became socially withdrawn, and like it was really disturbing, like the things he was going through. So obviously, even if people aren't dying in your study, that doesn't mean that you've done a completely ethical study. They could still be psychologically or mentally scarred, okay, depending on what your study is about. And so nowadays, our ethics committees are very concerned with making sure that even the littlest bit of harm doesn't happen to participants. And that's why ethics committees have developed these ethical principles, okay? And we use this memory tip, and you've used this last year as well, I think, if you had this PowerPoint, called Perhaps Very Intelligent Ducks Can Do Well. So obviously it's just an acrostic, and each of the first letters corresponds to the first letter of the ethical principle. So perhaps is the P, very is the V, I is the intelligent, and I is the informed here. Yeah, you kind of get the point. So perhaps very intelligent ducks can do well is our memory tip that we use. Alrighty, and we've got 2 pictures of intelligent ducks here, so try to remember that in your head so you can remember the memory tip. Alrighty, let's go. So the P for obviously perhaps comes from the P for protection and security of participant rights. This is also, if I can do my little drawing thing. Will this work? Let's see. This is also called the no harm principle, okay? You might have come across this. That's why I put this picture set that says do no harm. So when you come across the no harm principle, I can't even write, oh my God. Okay, the no harm principle is basically another word for protection and security of participant rights. Now, why can't we just call it the no harm principle and not call it protection and security? Well, because in the study design, the terminology they use is protection and security of participant rights. So that's the one we want to use. Obviously, when you're memorizing this or when you're learning this, you can just you can just use the do no harm as like a summary of what this entire ethical principle is about. So essentially what protection and security of participant rights means is that researchers must always protect their participants' interests and needs and make sure that the safety and well-being of those needs of those participants is always met. So participants should never be put into unnecessary pain, distress, danger, or hazards, okay? And this little clip here, I don't know if you guys recognize this, but this little clip here, this photo is taken from a clip which is taken from the BBC recreation or replication of the Milgram experiment. And it's actually showing one of the teachers in the Stanley Milgram's experiment who was asked to deliver the electric shocks. And that after he got to a certain point, he was clearly distressed about what he was doing. And he was like putting his hands into his face, and he was like completely like visibly distressed and visibly affected by this. So again, we don't want participants to go through that. Participants haven't signed up to be tortured. They've signed up to be participants in your study. So we have to treat them accordingly and give them that sense of protecting them from that mental and emotional trauma. Alrighty, so the next one that we go through is voluntary participation. Okay, voluntary participation is again related to before the participants are in the study. So before the participants get involved in the study and they're chosen for the sample, voluntary participation is us asking, okay, have they been forced to be in the study, or are they participating out of their own free will? If they are participating out of their own will and through their own choice, then that essentially means that they were not forced to sign up to the study. Now, remember, don't confuse voluntary participation with withdrawal rights. Withdrawal rights is a right you exercise once you're in the study. Once I'm in the study and I'm a participant and I want to leave now, I want to get out of the study, that's withdrawal rights. Voluntary participation is even before you get into the study. Okay, it's whether you're forced to be in the study or you come into the study with your own free will. Now, obviously, voluntary participation, if someone is forced to be in a study, that is clearly an obvious indication that voluntary participation has been breached or violated. But another example could be, like I said before, if someone is offered money to be in a study, if someone is offered a gift card to be in a study, if someone is offered, if someone is told that I'm going to deduct 5 marks from your SAC average if you don't participate in this study, all of these are also signs that voluntary participation has been breached as well. Okay, they're not as obvious as as a researcher just forcing someone to be in a study, but they are still kind of obvious. And that says breached, not bread, even though it looks like bread. Okay, I'm not really good at writing with this. I don't know why. Okay, anyways, so that's what voluntary participation is about. The next thing that we look at is, whoops, need to get back to mouse. Okay, informed consent. So informed consent, we all know what it's about. Informed consent is the person kind of ticking off that, yes, I want to participate in this study. But remember, it's more than them just signing a consent form. A lot of students, what they think is that, oh yeah, what's it called? What was I going to say? Informed consent is just about the person, you know, signing a consent form, saying that they need to, that they're okay with participating in the study. But remember that the word is informed consent, okay? Informed means that they're not just simply signing a form and giving consent, they're being informed before they do that, okay? So all of these things, 1, 2, 3, 4, all of these 4 points are kind of like talking to us about what the informed part of informed consent is about. So obviously, in order to inform my participant, I'm giving them the nature and the purpose of the study. I'm giving them a detailed understanding of any potential risks that are involved. If I'm doing a study using some kind of X-ray technology and testing that, or I'm using MRI or some kind of computer scan, I need to write in my study that if you've got a pacemaker, or, you know, if you've got any metal joints or any kind of metal things in your body as a result of surgeries or whatever, that you cannot participate in this study because you might be potentially harmed. I can't just tell them at the last minute before they're going to go into the MRI scan thing that, oh, actually, you know what, did you have a pacemaker? Because I kind of forgot to ask you. You can't do that. You have to tell them in advance. Information about any tasks or procedures. So obviously, we need to clearly list out what are the different tasks and procedures that the participant is going to do, so they clearly know what to expect. We can't just be like, surprise, and spring it upon them, okay, at the last minute. We have to make sure it's all detailed there on the informed consent sheet. And the withdrawal rights. So the withdrawal rights is the participant has to be told that you have the right to withdraw from this study at any time without any pressure or without any judgment, okay? And so they need to feel comfortable to know that, yes, if I need to, for some reason, leave the study, or I'm not feeling well, or I just don't want to participate anymore, that I won't be given a lot of, crap about doing that from the experimenter, or the experimenter won't chase me up on it or make me feel bad about it. Okay, so obviously informed consent is extremely important. It's like a mini contract that is had between the experimenter and the participant, as we see in this image here, okay? And in the same way that in a job contract or in an employment contract, you would put in all the details in extreme, like extensive length, you need to do that with your informed consent form as well. Okay, so remember, when you're writing a definition for informed consent, or if Vika asks you, okay, what is the significance of informed consent for this study, you don't write, it's just about signing a consent form. You need to write, what are the different things involved? So these are the 4 main things every informed consent procedure must undertake or must involve. Alrighty, so, oops, go back to mouse. Okay. The next thing is deception. So deception is when we deceive participants, and how we deceive them is we withhold particular information about the study. Now, not every study uses deception, okay? Not every study uses deception, but if you're doing a study where the participant shouldn't know something about that study, or the participant shouldn't be able to come to some expectation about that study, well then, yeah, you can actually deceive them. But whenever deception happens, debriefing has to happen. You have to tell the participants that, hey, just to let you know, we did deceive you. We did tell you something about the study which wasn't true, and this is the reason we did that, and this was the actual nature of the study. You can't deceive the participants and just say, okay, bye, and not tell them what was the actual true nature of the study. So deception was used in Milgram's study when he did the experiment thing with the electric shocks and the teacher and the learner. Obviously, because if the participants knew that they were not administering electric shocks to a real person, they might have been like, what the hell, what is this crap? I'm going to leave this study. I don't want to be in this study anymore. Why should I deliver electric shocks to a radio recording of a person's voice? Like, you need to deceive participants in some instances. It's not preferable, obviously, but sometimes you have to, and that's fine. And there is an acceptable level of tolerance for that, as long as debriefing happens immediately after the study is done. Okay. Also, oh wait, sorry, no, this is deception. So when we look at debriefing, I'll talk about that. Okay. The next thing that we look at is confidentiality, and you had a question on confidentiality in your quiz yesterday. Okay, so confidentiality is pretty simple, making sure that participants are not being able to be identified in any way, making sure that we do store and secure participant results or assessment sheets or data in a safe and private manner. We're not just posting it up to Facebook or LinkedIn or any of these websites, and we are making sure that that participant knows that whatever I wrote about in that study, whatever I did in that study, will not be revealed to anyone, okay, without getting my prior permission first. So obviously, it's important to maintain confidentiality because it maintains the researcher's integrity, okay? And it makes sure that that participant will then participate in research in the future as well if they need to, because they trust that the experimenter will respect their privacy and respect their confidentiality. Debriefing, again, whenever deception occurs, debriefing has to occur, but not necessarily always, okay? So I'll give you an example of what I mean. Now, when we're talking about debriefing, like I said, debriefing usually happens when deception happens. If I've deceived my participants in some way, then I have to debrief them. But I can also debrief participants in other cases as well. So if, for example, my participants look like they're pretty shaken up by what was in the study, or something has triggered them in the study, or they feel a little bit worried or stressed. As a psychologist or researcher, you can then sit down with them and be like, okay, you seem a little bit stressed. Are you okay? Do you want me to refer you to the local psychologist or local counselor? Do you need some extra support? Here's my number. Here's my email. Let me know. So debriefing most commonly occurs when deception is used, but the researcher might decide to conduct debriefing for certain participants if they feel like these participants have been affected by the study. And remember, everyone is different. So even if you're doing a pretty laid back, pretty easy study, some participants might get affected by even a laid back study. Okay, you don't know what prior experiences that people bring with them to the table. Certain people can get triggered very easily by certain images or certain things. And so obviously it's important for the researcher to be able to make them feel at ease, make them be clear if there were any confusions about the study, and make sure that the participant is leaving that study knowing that they've been given that support. Okay, so debriefing can be used for these purposes as well. And some participants are like, they just love to know everything. So they might want to sit down with the researcher and know about, for example, what were the results of the study? How are you going to use these results? Okay. Very few people would actually want to do this, but again, there are people who might actually be legitimately participating in the study just for that research knowledge. Okay. Okay, I think we're almost done. So withdrawal rights, again, not going to spend too much time on this, but we know that withdrawal rights is just the right for you to leave the experiment at any time. We know that there are cases of experiments where, especially where little kids are involved, especially kids like little Albert who could barely speak, they're not going to be able to verbalize their need to leave the study. He can't speak up and just say, actually, John Watson, you know what, I'm not going to leave the study. I'm going to leave the study. But what's it called? John Watson should have known. So you need to look at other cues, okay? Especially if you're dealing with babies, you've got to look at cues like, okay, are they crying? Do they seem clearly distressed? Do they seem like they don't want to be here? So you've got to sometimes use emotional cues as a way of understanding whether someone wants to withdraw or leave the study. Now, obviously, withdrawal rights need to be told or need to be informed about to the participants within the informed consent procedure. And researchers can also remind participants of this right at any time during the study as well. Okay, so if a participant looks like they're super stressed, I, as the researcher, can go up to them and be like, are you doing okay? Remember, if you want to leave, if you're not feeling comfortable, you can leave at any time. Okay, and obviously as a researcher, if you do that, it shows that you are responsible and that you are looking out for your participants. Okay, now how do you determine withdrawal rights in a particular study? Well, if your research scenario is saying that, okay, participants had to complete the full number of tasks over the 5 number of days of the study and could not leave the study until they completed all tasks, or participants were asked to complete all tasks in the study and could not leave the study until they completed all tasks, or the researcher would deduct 3 marks from their grade and tell their professor at the university to do that. Okay, that would all be a potential breach of withdrawal rights, because you're not allowing the participant to leave the study when they want to. And remember, as a participant, you don't have to be traumatized. You don't have to be feeling mentally uncomfortable to leave the study. Even if you get the vibe that something's not right, or you know what, I don't want to do this anymore, you can just leave. You don't need to be bawling your eyes out or looking like you're completely traumatized in order for you to leave. Okay, you don't need to give a reason, because your participation there is completely voluntary and you're not really getting anything out of that in most cases. All right, now before we finish off, just looking at the use of animals in psychological research. I'm not going to go into this a whole lot, but again, it is a key study design dot point. So I thought we'll just go through this in one slide. So we know animals are used in psychological experiments and studies. We've done so many studies this year, or we've looked at so many studies this year and last year that do use animals. Okay, so when we looked at last year, when you looked at Harlow's experiments with the rhesus monkeys and attachment, okay, he was using monkeys in his study. And monkeys are very similar to humans in terms of attachments and physical comfort and the need for physical closeness. So that's why he chose monkeys for his study. If we looked at Pavlov's experiment, he used dogs. If we look at Skinner's experiment and the Skinner box, he used rats, and he used pigeons as well in another study. So obviously there are some reasons or advantages or good things about using animals in studies. Number one, sometimes we simply can't do studies on humans. So it's better for us to do them on animals. And I know this sounds really unethical and mean, but like the main explanation for this is that, you know what, it's easier for us to breed animals as it is to breed humans. Okay, it'll take us about 9 to 12 months to, you know, breed another human, whereas it might just take you a few days or a few weeks to breed another rat or another dog, for example. Okay, human participants might not be available to participate, so we might have to use animals as a result of this. The body systems or behaviors of some animals are similar to those of humans. So we know that with apes or with monkeys, their brains are kind of similar in terms of the structure to humans. So we might use them as a starting point to get us started with investigating some form of behavior there. Animals don't have expectations, and so your placebo effects are completely ruled out when we talk about animal studies, okay, which means that you might be getting more reliable results. Obviously, the dog in Pavlov's study, he doesn't have this expectation, okay? Eventually, he's trained to have the expectation that the bell will cause him to salivate, but originally in the before conditioning stage, the dog doesn't have this expectation that, oh, this is how the study is going to play out, okay? Animals are very objective in that sense. They don't have subjective expectations and subjective opinions, okay? At least not that we know of. In certain studies as well, use of animals can be effective in terms of time, less time consuming, because if we are studying the biological impacts of stress or how stress affects the body, it's going to be too long for us to study a human from until they're born and then until they die and just track the stressful events that they go through in their life. But because animals have lower life expectancies, I might be able to assess the impacts of stress on a rat in the space of maybe 1, 2, or 3 years as compared to a human, which would take like 70 or 80 or 60 years. Okay, it's a much longer time. Now, some of the disadvantages of animal studies, and we're nearly done. Number one, animal studies are done with animals. They're not done with humans. And obviously, even if animals can be similar to humans, they aren't humans, okay? So we can never generalize results from animal studies, okay? The second thing is that just because animals are like a lower species or like, you know, a less like kind of like a helpless species that we control over or that we dominate, that doesn't mean we should dominate over them just because we can, okay? And a lot of the time, animals, they don't have that ability to fight against humans or to decide that, hey, I can actually escape from this cage, okay? Especially when you're imprisoning these animals, you don't really know if they are voluntarily participating or not. Also, animal research can be quite controversial because it can be hard to ensure that the animal's not being harmed. Again, animals don't show pain in the same way that humans do. They do feel pain in the same way humans do, no doubt, but it's hard for us to make out that emotion in their faces. So it's hard to ensure they're not being harmed. And obviously, in the case of drug testing and cosmetic testing, there's been a lot of controversy around how people will pour like a chemical into rabbits' eyes to see whether that chemical will lead to blindness in humans. And that's not fair that an animal has to go through that just for a human need. Okay, and lastly, as with all research, beneficence must be practiced. So beneficence is another word for the no harm principle or for the protection of security and participant rights. Beneficence means that the benefits that come out of the study must always outweigh or be greater than the harm or the bad things that will come out of their study. And so we can apply this to human studies, but we can also apply this to animal studies, that we shouldn't completely torture an animal just because we can easily access them and easily put them in a cage and force them to do what we want them to do. That's just not fair. Okay, so that's the use of animals in psychological research. Right, and now we've actually come to our last slide, which is good. This slide isn't really a content slide, it's just more of a skills-based, looking at like what are the different reporting conventions. So obviously you guys know from doing your poster SAC last year that you've got your introduction, you've got a discussion, you've got results section, you've got references. It's just knowing what those sections are. And it's just basically knowing that these conventions that you're using, or APA formatting, APA conventions, these are conventions that are used both in VCE level and in university level. And on top of that, these are things that you are going to be assessed on in your outcome 3 SAC, which is going to be your poster or your research report. Okay, and we're going to be doing that a few weeks into when we get into school, when we start next week. So a few weeks in, after we've completed our research methods, we've done a few practice questions, and we've conducted our study together as a class, we will start working on that. So this is more of a skills-based slide. Alrighty, so that is the end of our research methods PowerPoint finally. I'm just going to probably stop the recording here.